Hello dear aspirants, this is Dr. Sourav Sir's classes. Our contact number is 98367930076. Again, I am repeating our contact number, which is 98367930076, and our email ID is souravsirclasses@gmail.com. So if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or you can WhatsApp also. Rather, you can drop an email to our email ID. Then our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions and our online classes. So that will be beneficial for your preparation of upcoming examinations like ISI, CMI, TIFR, NBHM entrance exams or any other higher mathematics entrance exams and your semester exams also. So please feel free to contact if you need any help from us. Okay. So now we are going to solve a problem which is appeared in the IIT JAM Mathematical Statistics question paper, and the question is telling us that suppose f is a polynomial of degree n with real coefficients and a is an n cross n matrix with real entries satisfying f of a is equals to 0, and consider the following statements. So the first statement is telling us that if f of 0 is not equals to 0, then a is necessarily non-singular, and statement 2 is telling us that if f of 0 is equals to 0, then a is necessarily singular. So then we have four options here which are telling us that our statement 1 is incorrect and statement 2 is correct. Statement B, option B is telling us that both the statements are correct. Option C is telling us that both the statements are incorrect, and option D is telling us that the first statement is correct and the second statement is incorrect. So what can be done with this? So we are tasked with analyzing two statements about a polynomial f and a matrix A. Let's carefully evaluate each statement. So the statement 1 is telling us that if our f of 0 is not equals to 0, then our A is necessarily non-singular. Okay. So if our f is polynomial of degree n with real coefficients and our f of a is equals to 0. This is given in the question. This means a is a root of the polynomial. So if our f of 0 is not equals to 0, then 0 is not a root of it. We can easily say that the 0 is not a root of this polynomial. So this implies that it cannot have 0 as an eigenvalue, because if 0 were eigenvalue, then f of 0 has to be 0, because our since our f of a equals to 0 holds, so 0 is not an eigenvalue of a. Thus we can say that the determinant of a can never be 0, so our a will be non-singular. Yeah, so our first statement, the statement 1, is absolutely correct. So now we have to understand the statement 2, which whether this is false or not. So the statement 2 is telling us that f of 0 is equals to 0. Then a is necessarily singular. Okay. So if our f of 0 is equals to 0, then 0 is a root of f. This means a could have 0 as an eigenvalue, but it is not guaranteed. For example, consider the polynomial f of x is equals to x. Okay, so here we can easily see that our f of 0 is equal to 0, but A could be the 0 matrix or a non-zero matrix like a 2 cross 2 Jordan block with eigenvalue 0. Then also our minimal polynomial will be what? Then the minimal polynomial is this, is x square, and the characteristic polynomial is also x square. Yeah. So A could also be a non-singular matrix that can satisfy f of a equals to 0. So thus f of 0 is equals to 0 does not necessarily imply that our a is singular. Okay. So the statement 1 is correct statement and our statement B is false statement. So we can write that the correct answer of this question will be what? That will be our option D, which is telling us that the statement 1 is the correct statement and our statement 2 is the incorrect statement. Okay. So again, I am telling that if you have any other mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number on or you can WhatsApp also. Rather, you can drop an email to our email ID, which is written in the screen, which is souravsirclasses@gmail.com. Then our team can arrange a doubt clearing session for you. After that, you can join our join as a student to our institute. Then you can enjoy all the services of Dr. Sourav's classes. Okay. Thank you guys. Hope you understood. Thank you.